Hello everybody, welcome to day 3 of Credit 6. We're starting off with just this basic definition that anything to the power of n could be written like this. It's repeated multiplication, b times b times b times b, n times, right, n factors, and also b to the 0 power is equal to 1. So this is any number to some power is just, that's how many times you're going to multiply it. So 2 to the 3rd power is equivalent to 2 times 2 times 2. So 3 times. And this is the number multiplied times itself 3 times is what that means right there. And if you have any number, so 2 to the 0 power is equal to 1. Okay, it's like you multiply it times itself no time, so it's just 1. Also, b can never be equal to 0 in this case, because weird things happen when you take 0 to the 0 power. Is it equal to 1 or is it equal to 0? So we don't really know. Okay, so this is sort of off the table. Okay, so we're going to use that definition and figure out, do a little investigation with some different numbers here and find out some values that make this statement true. Okay, so I would recommend, this is your hint, that you write this out using that definition. So 2 times itself 10 times. 2 times 2 times 2. So there's 4, 5, 6, 7, 8, 9, 10. And then I'm going to multiply that times 2 times itself 3 more times. So 1, 2, 3. And that's equivalent to 2 to the what power? Well, to make this statement true, y would have to be equal to, let's see, I have 10 of these and then 3 more, so that's 13, right? So if I said y equals 13, this would be a true statement, right? And I'd go ahead and do that on all of these. Go ahead and write out the full version and find out what values would make all of these statements true. And then tell us what pattern you figured out. Is there a shortcut, right? Is there a shortcut to getting that value that will make the statement true? Okay. Here we have some common mistakes that people make with exponents, and what we want you to do is explain to the student why this is wrong. Okay, so again, go back to that definition. Use the definition to show that this in fact is something completely different than equaling 15. Okay. Then we jump down to this power of a power. So we have something inside parentheses and then that whole thing to the power. So just go back to the definition again. 2 to the 3rd times itself 4 times, right? 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. So 4 times itself is equal to 2 to the z. So what value of z makes this statement true? And you could jump to the definition again and multiply the 2's 3 times, right? 2 times 2 times 2, 2 times 2 times 2, and so on. So that's 2 to what power? Okay, and just go back to the definition on all these, and then see if you can come up with a shortcut. What's something that would be true in every case? Can you take these numbers to get the value of z in a shorter fashion than writing it all out? Because I'm sure if I wrote down something like 2 to the 50th power to the 10th power, I'm sure you're not going to write out all those 2's. So what's the value of x on something like that? Okay, and then power of a product. So now we have a product of 2 numbers to a power. Go back to the definition again. So 6 times 11 times 6 times 11. 3 times itself, right? And then I can regroup these, right? So it's 6 times 6 times 6, and then 11 times 11 times 11. So that's equivalent to 6 to some power, 11 to some power, right? So what values of x and y make that statement true? And then see if you can come up with a rule that you can kind of skip this step and go straight to the values of the exponents that would make the statement true. Okay, and then write about in your math notebook. Reflect upon the properties of exponents by answering the following questions. So there's a number of problems here that you can do and reflect on in your notebook. Okay, and then we get to quotients of powers. So quotients of powers, so we have 2 to the 10th power, so 2 times itself 10 times. And then, divided by 2 times itself 3 times. So you see that 2 divided by 2 is just 1, so 1 times anything is just itself, so it would go away. And these would cancel, and these would cancel, so I'd be just left with a 1 in the denominator, and anything divided by 1 is just just the number. So I have 2 times 2 times, so 7. So is equivalent to 2 to the 7th, right? Is a value for z that would make that statement true. So go ahead and do that with these other ones and see if you find a pattern with those. And you can go ahead and answer those questions there. And then finally we get to negative exponents. So negative exponents, we bring in this new kind of definition. So b to the negative n is equivalent to 1 over b to the n. And so our justification for that will have to do with those rules that you came up with, right? So think about those rules that you came up with for finding the quotient of two things, 2 exponents. Okay. So with that little investigation, you should have a good understanding of how to use exponents in algebra.